Hello Year 11 and welcome to your maths lesson today. We're going to be looking at index laws. It is something we've looked at in lessons before, but I thought we would review this topic today because there are quite a few of you that weren't able to answer the question on the Swatch exam paper on index laws. So we'll have a review today and then hopefully you'll be able to answer those Swatch exam questions too. So if you can write the date and the title into your books. So it's index laws and the date is the 13th of January 2021. And the first index law that we are going to look at today is when we are multiplying. So we might have y to the power of a multiplied by y to the power of b. And some of you might recall here that when we're multiplying, we add the indices. So our answer would be y to the a plus b. So we're going to look at why that happens, why that works. If we had y to the power of 2 multiplied by y to the power of 3, we know that y to the power of 2 is y squared, which is y times y. And then we're multiplying that by y cubed, which we know is y times y times y. Now we can see that we're multiplying y by itself 5 times here. Okay, so we could write that in index notation as y to the power of 5. So you can see there why it works that we add the indices. So 2 plus 3 gives me the 5 there. So let's have a look at a few examples. If we have w to the power of 3 multiplied by w to the power of 5, we add the indices together, so our answer would be w to the power of 8. This also works for negative numbers, so if we had a to the power of negative 2 multiplied by a to the power of 5, we would still add the two indices together, so we'd have negative 2 plus 5, which is going to give me a to the power of 3. Now sometimes we might also get numbers in front of the letters, so we might have something like 2 multiplied by y to the power of 6 multiplied by 5 times y to the power of 4. So with these numbers that are in front of the letters, we just multiply them as we usually would. So 2 times the 5 is going to give me 10. And then I've got y to the power of 6 multiplied by y to the power of 4. So in that example, I add the indices because we're multiplying. So it would be y to the power of 10. So my final answer would be 10 multiplied by y to the power of 10. Now if you want to pause the video here and catch up with any of those examples that you haven't written down, and then we'll have a look at the next index law in a moment. So our next index law is when we are dividing. So we might have y to the power of a divided by y to the power of b. And again, you might recall here that we have to subtract the indices when we're dividing. So our answer would be y to the power of a subtract b. So you do them in the order that they appear. So it's a subtract the b. Okay. Now let's have a look at why this will work. If we had, for example, y to the power of 5 divided by y to the power of 3. Y to the power of 5 actually is y times y times y times y times y divided by y to the power of 3, so y cubed, y times y times y. Now, you know that when you divide something by itself, it equals 1. So we can do some cancelling here, and we can say y divided by y is cancelled out, and that it just equals 1. Y multiplied by y, and y multiplied by y. So divided by y. So that means that we're just left with this bit here, okay, which is y multiplied by y, which we can write as y to the power of 2 or y squared. Okay, so you can see here that we've subtracted the indices. We've had y to the power of 5 divided by y to the power of 3. So 5 subtract the 3 equals y to the power of 2. So 5 subtract 3 equals the 2. Let's have a look at a few examples of this. If we had w to the power of 8 divided by w to the power of 2, we would subtract the indices. So 8 subtract 2 is 6, so our answer would be w to the power of 6. Again, we can have negative numbers as indices. So if, for example, I had a to the power of 4 divided by a to the power of 6, I've got to do them in the order that they appear here. So it's going to be 4 take away the 6, which means I'm going to get a negative indice, but that's fine. So that's going to be a to the power of negative 2, because 4 take away the 6 is going to give me negative 2. And again, like with the multiplication, we can sometimes get numbers in front of the letters as well. So we might have something like this, where we have 24 multiplied by w to the power of 6 divided by 2 times w to the power of 2. Okay, so as you all know, sometimes you're going to get a division symbol like this, and sometimes you can get a division symbol like this. They both mean exactly the same. So as with the multiplication, where we've got numbers in front of the letters, we're still just going to do this division. So 24 divided by 2 is going to give me 12. And then I've got w to the power of 6 divided by w to the power of 2. So I'm going to subtract the indices to give me 6 take away 2 to give me w to the power of 4. So my final answer would be 12 multiplied by w to the power of 4. Again, pause the video here if you need to catch up with writing any of these examples down. Our third index law, and again this is one that you might remember, is where we have y to the power of 0 equals 1. So anything to the power of 0 is always going to equal 1. Okay, so if you think about some of the index laws we've already looked at, if we had something like y to the power of 3 divided by y to the power of 3, we know that anything divided by itself is always going to equal 1. And if we use our index laws here, we know that we're going to subtract these two indices here. So 3 take away 3 is 0, so it would be y to the power of 0, and we know that that's got to equal 1. So looking at a few examples, if we had x to the power of 0, that would equal 1. If we had 10 to the power of 0, that would equal 1. If we had 25 to the power of 0, that would equal 1. Okay, so absolutely anything to the power of 0 is always going to equal 1. Now the last index law that we need to look at is where we are raising a power to another power. Okay, so this is where we have y to the power of a, and then all of that raised to the power of b. Okay, and our law here is that that's going to give us y to the power of a times b. Okay, remember when we've got two letters next to each other, we multiply them. So looking at an example of that, if we had y to the power of 3 and then all of that raised to the power of 2. So we know that when we're raising something to the power of 2, we're squaring it. Okay, so we're squaring what's inside the bracket, so that'd be y to the power of 3 multiplied by y to the power of 3. And we know that when we're multiplying, we add our two indices, so that is going to give us y to the power of 6. And you can see here that we've multiplied these two indices here to get the power here. So when you see something like this where you've got the brackets and you're raising something to the power in the bracket by another power, that you multiply these two indices together as your indice for your answer. So let's have a look at a few examples. If we had y to the power of 4 and then all of that raised to the power of 5, we're going to multiply our two indices together. 4 times 5 is 20, so our answer be y to the power of 20. Again, with negative numbers, the same rules apply. So if we had a to the power of 4, and then we raise that to the power of negative 2, we're still going to multiply our two indices. So we're going to have a to the power of 4 times negative 2. So a positive number multiplied by a negative number is going to give me a negative answer. So it's going to be negative 8. And again, if we have numbers in front of the letters, we're still going to use the same method. So if we had 2 times y to the power of 3, and then all of that raised to the power of 2, or all of it squared, what we're going to do first is we're going to square the number in front here. Okay, so we're going to raise this number here to whatever power we've got here. In this example, we're squaring. So 2 squared is 4. And then we're going to do the same with the powers here. We're going to multiply those together. So we've got y to the power of 3 times 2, which is 6. I'm going to show you another example of one of these. And that's where we've got 3 multiplied by y to the power of 5. And all of that then raised to the power of 3. So the first thing we're going to do is we've got the number in the front here. So we're going to raise that to the power outside. So it's 3 cubed. So 3 times 3 times 3. So 3 times 3 is 9, times 3 is 27. Then I've got my y, and then I'm going to multiply my two powers here. So I've got 5 times 3 is 15. Again, if you can pause the video and catch up with any of the examples here before we move on. Okay, so now that you've written down all of the index laws, and hopefully you can remember some of them to start with, I'd like you to have a go at these practice questions. You can either pause the video now and read them off the screen, but I have loaded these onto Go for Schools as a Word document as well. So where it says here to write as a single power of 2, it just means that your answer is going to be 2 to the power of something. So it's just a single power rather than here where we've got like 2 powers. Okay, so for our first example here, we're multiplying, so we're going to add the indices together. So 2 plus 2 is 4. So our answer would be 2 to the power of 4. So we've got some multiplication, some division, both types of division here. Okay. And then there's some powers down here as well when we're raising a power to a power. And then down here we have some mixed ones here, so you have to choose which index law you are going to use. So if you'd like to pause the video now and either copy these off the screen and do them in your books, or you can print the Word document from Go for Schools and either complete it on the Word document or complete it in your books. It's up to you. So I just want to finish off with the 2 questions from the Maths Swatch exam. So our first one is z to the power of 3, and then all of that raised to the power of 4. So hopefully now all of you would be confident in completing that question. So we're going to be using our last index law that we looked at to multiply the 2 indices together there. So we would have z to the power of 12. We've then got this more complicated one down here. It's a division one, okay? So we know where we've got indices, we are subtracting the indices. We've also got numbers at the front here, which means that we need to do that division for the numbers as well. So if we look at those first, we've got 18 divided by 2, and that is going to give us 9. We've then got x is raised to the power of 8 and x raised to the power of 5, and then we've got y to the 5 and y here on its own. Now you've got to deal with the x's separate to the y's, okay? So we're looking at the x's here, so we've got x to the power of 8 divided by x to the power of 5. So we're going to subtract those indices, so we're going to have x to the power of 8 subtract the 5, so that's x to the power of 3. Then we're going to have a look at the y's. So we've got y to the power of 5 divided by y, and there's no power there. So when there's no power there, we know it's just a y to the power of 1. It's just y on its own. Okay, so we still need to subtract those indices. So we've got 5 take away 1, which is y to the power of 4. So there's your two answers to the math swatch. Hopefully you've been able to work those out now. If you've got any questions, then email me. You can join the live Teams call when we'd usually have maths, and I'll be on hand there to help support you in completing this task, and we can go through the answers for the practice questions as well. Okay, enjoy and have a good day.